So, flip the page, we'll do some examples and we'll call it a day. So these ones are relatively simple. These are just one-step equations. I'm going to give you a whole bunch of time to practice doing them, but these are just one-step equations. One-step equations means you should be able to solve these things using only one operation. What we want to do is we want to isolate the variable using opposite operations. It doesn't matter what side the variable ends up on. So let's do a couple examples. If I've got x plus 7 equals 11, and I want to get x by itself, because we're adding 7, what am I going to have to do to get x alone? Yeah, I'm going to subtract 7, and whatever you do to one side, you have to do to the other. On this side, the positive 7 and the negative 7 are going to cancel. On the left side, we're left with just x, and on the right-hand side, we've got 11 minus 7. 11 minus 7 is, if you need a calculator, you can use a calculator, but you should be able to do 11 minus 7 in your head. That's 4. Relatively straightforward, yes? Question 2, what would I do? Sorry? Yeah, that's not what you said the first time, was it? So we've got x minus 4, and I want to get x alone. I want to remove the other values that are over here on this side, so I'm going to have to do the opposite of what's there. If I'm taking away 4 to get it alone, yeah, I'm going to have to add 4, and whatever I do to one side, I have to do to the other. So the negative 4 and the plus 4 cancel, and I'm left with x. That's going to equal 2 plus 4, which is? And if you want to go back and check it, we can check it relatively easily. To check these things, take the value you got and plug it back into the original equation. We started with x minus 4 equals 2. If I want to check to see if my answer is right, take the value you got and replace it back in for the variable. Is 6 minus 4 equal to 2? Yeah, so you're good. Algebra has a built-in method for you to check these things relatively easily. Let's do a couple more. I've got 6 plus x equals 4. I want to get x alone. Now, the 6 over here is positive, so what am I going to have to do to get x by itself? I'm going to take away 6. Thank you, Liam. 6 minus 6 is 0. X is going to equal what? Negative 2. Because 4 minus 6 is negative 2. So we can look at take a look at our check, right? I started with 6 plus x equals 4. If I take this value and I substitute it into our equation, is 6 plus negative 2 equal to 4? Is this true? Well, adding a negative is the same thing as taking something away. Is 6 minus 2 4? Yeah, so we're good. What do I do with something like this? I have negative 2 plus x equals 8. Dilkaran. I want to add 2 to both sides. You bet. So it doesn't matter what's going on right here. And you got to be really careful with this. This is where I see students make mistakes with something so simple. It doesn't matter that you're adding here. Sometimes students will see this and think, oh yes, I want to subtract. It matters what sign is out front of the value you're trying to get rid of. Because this thing is negative, to get rid of it, Liam and Jackson, we're going to add 2 to both sides. This value is negative. I'm going to add 2 so that these cancel. So x is going to equal what? Yeah, you bet. Okay, let's do another one. 6x equals 24. Now we're not adding anymore. Jackson, I want you to move back a seat. Yep, grab your stuff, just slide back. You and Liam keep talking. So just move back. And you haven't written anything down, so not everything. So I have 6 times x equals 24. What am I going to do to get x by itself? Yeah, Juno. Yeah. Keep going. Whatever I do to one side, I have to do the other side. Here, when we were adding and subtracting, I wanted to add and subtract the opposite to give us something that added or subtracted to 0. Here, what I want to do is I want to multiply or divide to give us something that's equal to 1. So 6 divided by 6 is 1. 1 times x is just x. And then we've got 24 divided by 6, which you said was 4. Cool. So what am I going to do with this one? How is this one going to be different? I'm still multiplying. When there's no symbol written between a number and a variable, it's multiplication. So to get x by itself, I'm going to have to divide by what this time? I'm going to divide by -2. -2 divided by -2 is 1, because anything divided by itself is 1. We're left with x, and that's going to equal what? 8 divided by -2 is -4. And we can check just like we did before. Our equation that we started with was -2 times x equals 8. I can take the value we got for x and plug it back into the equation. Well, that's going to give me -2 and then in brackets -4. Is -2 times -4 8? Gabe? Is -2 times -4 8? Negative times a negative is positive. 2 times 4 is 8, so we're good. What's going on in 7 and 8? Here I've got x over 4 equals 2, and I've got x over -6 equals 3. Fractions are just another way to write division. So because here now I'm dividing, the opposite of division is? Aiden, wake up, because you're going to have questions about this. I just know it. I want to get x by itself. I want to get it alone. I want to get it in the numerator. It's already in the numerator. So what am I going to have to do to get x by itself here? The opposite of dividing by 4 is multiplying by 4. And whatever I do to one side, I have to do to the other. 4 divided by 4 is 1. We're left with just x. And 2 times 4 is 8. We can check. The question was x over 4. X over 4 equals 2. I can just take my value and plug it in. Is 8 divided by 4 equal to 2? You're good. So what am I going to do here? I've got x over -6 is equal to 3. So the opposite operation in this question is going to be, sorry, multiplication by, this time I'm going to multiply by -6. Whatever I do to one side, I have to do to both sides. -6 divided by -6, positive 1. So now my coefficient on the x is 1. That's what I want. That's what it means for the variable to be alone. And 3 times -6 is -18. Now, let's make a note here for 9 and 10. Isolating means x is alone in the numerator. So these ones aren't actually one step anymore. These ones we're going to have to do twice. X is in the bottom. We don't want x to be in the bottom. So the first step here is to get x up out of the denominator. This, the way this is written, means I have 5 divided by x. So to get x out of the denominator, what are we going to have to do? If I'm dividing by x, we're going to need to multiply by x. So these are actually going to be the first step into multi-step equations. We have to multiply that variable up out of the denominator. Sorry? We don't want it in the bottom. I'm not sure I understand what you mean, but that's okay. So if I multiply both sides by x, it jumps up to the other side. X divided by x is 1, so I'm just going to be left with 5 times 1, which is 5, equals 15x. Now I want to get x by itself. So what do I have to do? Divide by what is currently attached to the x? 15 is. So this is the thing right now I have 15 times x. I don't want 15 times x. I just want x. So we're going to divide by 15 on both sides. Here it's going to cancel, and we're going to get x on the right-hand side now is going to be equal to what? What's 5 over 15? 1/3. And you can leave your answers here as a fraction. Sorry? Questions about what I just did? We can check this if we want. If I have 5 over x equals 15, and I want to take this value of 1 over 3 and put it into the original question, what I'm going to get is 5 divided by 1 over 3. Let's think back to chapter 1. How do you divide by a fraction? You flip it and you multiply. So 5 divided by 1/3 is going to become the same as 5 times 3 over 1. What's 5 times 3? Which is what we started with. We said that 5 over x was equal to 15. If x is 1/3, 5 times 3 over 1 equals 15. We're good. This is the correct value. William, could you stop just shading on your work and maybe do some of the questions I'm working on here? Because you're going to tell me you don't get it. The rest of these are the same. Tilcron, wake up. Negative 3 over x equals 21. The procedure is the same. We're going to multiply to get that variable out of the denominator. Whatever you do to one side, you must do to the other. The x's on the left will cancel. On the right, I'll get 21 times x, which is just 21x. And now that x is up, x needs to be alone. We're going to divide both sides by what? 21. On the right, the 21s will cancel, leaving us with x equals what? Almost, not quite. Should be 0.1428, is it not? When you can, it's better to leave your number as a fraction. What's negative 3 over 21 as a fraction? Reduced. First of all, it's going to be negative. What do I do with top and bottom here to reduce it? Divide them both by 3. 3 divided by 3 is 1. 21 divided by 3 is 7. This is a totally acceptable way to leave that final answer. Where you guys are going to make mistakes is where you rush the method and get sloppy. Start with the one-step equations. Don't worry, they will get more difficult. I will leave you to play with some of this stuff now. Flip, I want you to work on the following. Oh, which ones do I want you to do here? I have a whole bunch of practice for you. I would like you to do you know what? I'm going to get you to do odds on this chunk here. Odds on question 1 to 29. Odds. You have like almost 40 minutes left of class here. You got lots of time. I want you to do the odds there, and I want you to do this page here. What is the difference between a yam and a TV announcer?
I can't.
You can do it. I believe in you. These first ones, just baby steps into the world of algebra. Single step questions. Good luck. Yes, I can go back to that page real quick. So 1 to 29 odds, and what is the difference between a yam and a TV announcer? You may go to the washroom. Rabin, you may go after Jackson comes back. Dil Karan, you can go after Rabin comes back. You want to work on all of this in the Indigenous room? Did you write down anything that I did here? Tell me. Yes, work on the boards, always. You don't ever need to ask to work on the boards.
More than Jackson did.
I'm not interested in whether it's more or less than Jackson did.
Yeah, that's another
Okay,
thing.
you can take yourself into the Indigenous room. Let me see what you took down. You wrote down nothing. No, you cannot get it. You don't try and engage with the lesson here, I'm not going to let you head down to LSS. Sorry? What was that, Hayden? I want you to try and engage with what we've got here before I let you go to LSS. One sec.